Right now, while you're watching this video, the farthest human-made object in history is still moving through the darkness beyond our solar system. It is not close to Earth. It is not near Mars. It is not orbiting Jupiter or Saturn. Voyager 1 is far beyond the planets, beyond the heliopause, beyond the protective bubble of the Sun, and it is still sending a signal back to Earth from interstellar space. But now that signal is in danger. Voyager 1 is running out of power. The spacecraft that survived almost 5 decades crossed into interstellar space, detected strange plasma signals, and came back from a near-fatal computer failure, is now facing something even more dangerous than distance. It is facing time. Every year, its power gets weaker. Every year, NASA has to turn off more of its instruments, and every shutdown brings Voyager 1 closer to permanent silence. And now, NASA has made a decision nobody wanted to make. Engineers have shut down one of Voyager 1's remaining science instruments, not because it failed, but because keeping it alive could have killed the entire spacecraft sooner. The low-energy charged particles instrument, known as LECP, was still working. It was still collecting data, but NASA had to turn it off to save power and keep Voyager 1 alive a little longer. NASA reported that engineers sent commands on April 17, 2026, to shut down Voyager 1's LECP instrument to conserve power. That one command changed the future of the mission, because this was not just an instrument being turned off. It was NASA buying time for something much bigger, something engineers have nicknamed the Big Bang. That name sounds like science fiction, but it is real. It is NASA's risky new power-saving plan, designed to keep the Voyager spacecraft operating longer than anyone thought possible. And if it works, it could extend humanity's only direct window into interstellar space. If it fails, Voyager 1 could go silent forever. This is the story of NASA's final fight to save Voyager 1. And to understand why this plan matters so much, we have to understand what Voyager 1 really is. It is not just a spacecraft. It is not just a machine. It is a survivor from another age. Voyager 1 launched on September 5th, 1977 from Cape Canaveral, Florida. Its original mission was to fly past Jupiter and Saturn, study their moons, rings, magnetic fields, and atmospheres, then continue outward into space. Nobody expected it to still be alive in 2026. Nobody expected it to become humanity's first messenger from interstellar space. But Voyager 1 kept going. It passed Jupiter in 1979 and changed how scientists understood the largest planet in the solar system. It saw Jupiter's storms, rings, moons, and radiation environment in detail humanity had never seen before. Then it flew past Saturn in 1980, revealing new details about its rings and moons. By that point, Voyager 1 had already become one of the greatest missions in NASA history. But after Saturn, the real journey began. Voyager 1 did not stop. It used the gravity of the giant planets to gain speed and moved outward, farther and farther from the Sun. Slowly, Earth became smaller behind it. The planets became distant memories. The Sun became only a bright star in the darkness. And Voyager 1 moved toward a boundary no spacecraft had ever crossed before, the heliopause. The heliopause is the edge of the Sun's protective bubble. The Sun constantly releases a stream of charged particles called the solar wind. That solar wind creates a huge bubble around the planets, called the heliosphere. Everything we know, Earth, Mars, Jupiter, Saturn, every human life, every city, every ocean, every moment in human history, has existed inside that bubble. Outside that bubble is interstellar space. And in 2012, Voyager 1 crossed that boundary. NASA recognizes Voyager 1 as the first human-made object to enter interstellar space, while Voyager 2 later followed. They remain the only spacecraft operating beyond the heliosphere. That changed everything. For the first time, humanity had a live scientific instrument outside the Sun's protective region, directly measuring the space between stars. Not from Earth, not through a telescope, not through a model. Directly. Voyager 1 was there, inside the darkness, sending back real data from the other side, and what it found was stranger than expected. Scientists once imagined the space beyond the heliopause as extremely thin, cold, quiet, and mostly smooth. But Voyager 1 detected signs that interstellar space is not just empty silence. It has plasma waves, it has density changes, it has turbulence, it has structure. The space between stars is not dead. It is active in ways we are only beginning to understand. That is why Voyager 1 matters so much. It is not sending us pretty pictures anymore. Its cameras were shut down long ago. It is not giving us colorful images of planets or moons. What it sends now is quieter, deeper, and more important. Measurements of magnetic fields, plasma waves, particle environments, and the invisible structure of interstellar space. This is the kind of science no telescope on Earth can replace. A telescope can look outward. A simulation can predict. A model can estimate. But Voyager 1 is physically there. It is touching the environment beyond the sun's bubble. It is measuring the actual conditions outside our solar shield. And that is why NASA is fighting so hard to keep it alive. But keeping Voyager 1 alive is becoming harder every year. The spacecraft does not use solar panels. It is too far from the sun for solar power to matter. Instead, it runs on radioisotope thermoelectric generators, which turn heat from decaying plutonium-238 into electricity. That system has powered Voyager 1 for nearly 5 decades. But plutonium slowly decays. The heat decreases, the electricity drops. NASA's Voyager FAQ says the spacecraft lose about 4 watts of power every year. 4 watts may not sound like much. But on Voyager 1, 4 watts is life. That is the difference between keeping an instrument warm or letting it freeze. The difference between measuring interstellar space or shutting down forever. The difference between 1 more year of science and permanent silence. Voyager 1 is not fighting a dramatic explosion. It is fighting a slow death by power loss. For years, NASA has been making painful choices. Turn off a heater here. Turn off a backup system there. Reduce power to one component so another can survive. Instrument by instrument, system by system, the spacecraft has been stripped down to its most essential parts. Every shutdown is a sacrifice. Every watt saved is another chance to hear from interstellar space. Then came the 2026 decision. On April 17, 2026, NASA shut off Voyager 1's LECP instrument. The low-energy charged particles instrument had spent decades measuring charged particles in space. It helped scientists understand the particle environment around the planets and later beyond the heliopause. It was part of Voyager 1's scientific soul. But NASA had no choice. The spacecraft needed power, the mission needed time, and shutting down LECP was considered the best way to keep Voyager 1 operating while engineers worked on a more ambitious fix. NASA said the shutdown should give Voyager 1 about a year of breathing room, while engineers finalized the Big Bang plan. That phrase, 1 year of breathing room, should stop you. Because it means Voyager 1 is no longer living comfortably. It is surviving. NASA is not planning for decades of easy operation. It is counting time in months, in watts, in commands, in fragile engineering decisions made from billions of miles away. And that brings us to the Big Bang. NASA describes the Big Bang as a power-saving fix for both Voyager spacecraft. The idea is to swap out a group of power devices all at once, turning some things off and replacing them with lower power alternatives to keep the spacecraft warm enough to continue gathering science data. That sounds simple. It is not. Voyager 1 is almost 49 years old. Its wiring, heaters, sensors, instruments, transmitters, and memory systems have been exposed to deep space for nearly half a century. Every change is dangerous. Every command is a risk. Nothing can be physically repaired. There is no rescue mission. There is no technician. There is no second spacecraft that can fly over and help. Everything has to be done from Earth by radio signal. And because Voyager 1 is so far away, communication is painfully slow. When NASA sends a command, it takes more than 22 hours to reach the spacecraft. Then the response takes more than 22 hours to come back. That means every test, every adjustment, every "did it work?" takes almost 2 days. During its 2024 recovery, JPL noted that a signal took about 22 and a half hours one way to reach Voyager 1. Imagine trying to save a dying machine, but every button you press takes nearly a day to arrive. Imagine waiting almost 2 full days to learn whether the spacecraft understood you. Imagine knowing that one wrong instruction could end the mission forever. That is what NASA is dealing with. And this is not the first time Voyager 1 has nearly been lost. In November 2023, Voyager 1 began sending unreadable data back to Earth. The spacecraft was still alive. Its signal was still reaching NASA, but the information made no sense. It was like hearing a voice from deep space, but the words had become scrambled. For months, engineers could not get usable science or engineering data from the spacecraft. Eventually, NASA traced the problem to Voyager 1's flight data subsystem, the computer responsible for packaging science and engineering data before sending it to Earth. Engineers confirmed that corrupted memory in one of Voyager 1's onboard computers had been causing unreadable data since November 2023. The cause was terrifyingly small. A memory chip had failed. One tiny piece of old hardware inside the farthest spacecraft ever built had nearly ended the mission. And because Voyager 1 was more than 15 billion miles away, nobody could replace it. Nobody could open the spacecraft. Nobody could repair the chip. So NASA did something extraordinary. Engineers worked around the damaged memory. They divided the affected code into sections and moved those sections to different parts of the flight data subsystem memory. Then they adjusted the software so the separated pieces could still work together. It was not just programming, it was remote surgery across interstellar space, and it worked. In April 2024, Voyager 1 resumed sending usable engineering data. Later, NASA restored science data from the spacecraft. JPL reported that Voyager 1 returned usable engineering updates for the first time since the issue began, and NASA later reported science data coming back again. That recovery proved something important. Voyager 1 is old, but it is not helpless. NASA can still save it, sometimes, but every rescue becomes harder. Every problem takes longer. Every repair carries more risk. And now, with power fading, the next rescue may be the most dangerous one yet. The Big Bang plan is not just about saving electricity. It is about buying Voyager 1 more time to continue science in a place no other spacecraft can replace. Right now, NASA's Voyager status page shows Voyager 1's cosmic ray subsystem is off to save power, LECP is off to save power, while the magnetometer and plasma wave subsystem remain on. Those two remaining instruments matter. The magnetometer measures magnetic fields. That is critical because interstellar space is shaped by magnetic forces that are invisible to the human eye. Magnetic field measurements help scientists understand how the sun's influence fades and how the galaxy's magnetic environment behaves beyond the heliopause. The plasma wave subsystem listens for plasma waves. It can help estimate plasma density in interstellar space. This matters because plasma density tells scientists about the material surrounding our solar system, the invisible environment through which the sun is traveling. Together, those two instruments are still giving humanity a live connection to interstellar space. If a Voyager 1 goes silent, that connection weakens dramatically. Voyager 2 is also in interstellar space, and it is still operating. But Voyager 1 is farther away. It crossed first. It is moving through a different path. Its measurements are unique. Losing Voyager 1 would not just mean losing one spacecraft. It would mean losing a scientific witness that cannot be quickly replaced. That is why this plan has such high stakes. The Big Bang could extend the mission. It could keep the remaining instruments alive longer. It could help NASA continue gathering data into the 2030s. NASA and JPL have said power conservation plans may allow the Voyagers to continue operating with at least one science instrument into the 2030s, though unexpected challenges could shorten that timeline. But the risk is real. The spacecraft is old. Its systems were never meant to be changed like this after nearly 5 decades. Some parts may respond exactly as expected. Others may not. A heater turned off to save power might cause a component to get too cold. A device swapped for a lower power alternative might behave differently than engineers predict. A command might succeed technically, but create a new problem somewhere else. And because Voyager 1 is so far away, NASA cannot react instantly. There is no live steering, no instant correction, no real-time troubleshooting. Every mistake echoes across space for almost 2 days before engineers even know what happened. This is why NASA is cautious. They do not treat Voyager like an ordinary spacecraft. They treat it like an ancient machine with one chance left. Every command is tested. Every sequence is checked. Every risk is discussed. The team knows that the same spacecraft that survived for 49 years could still be lost by one bad assumption. And yet, they are still trying. That is the part that makes this story powerful. NASA could simply let Voyager 1 fade. They could accept that the spacecraft has already done more than anyone expected. They could say the mission is complete, but they are not doing that. They are still fighting for one more year, one more signal, one more measurement from interstellar space. Because Voyager 1 is not finished telling us what is out there. The space beyond the heliopause is still mysterious. Scientists are still studying how the sun's bubble interacts with the local interstellar medium. They are still analyzing plasma waves, magnetic fields, and charged particle data. They are still trying to understand how the heliosphere protects the planets from galactic cosmic rays and how that shield changes over time. Voyager 1 is the only spacecraft that can answer some of those questions from its exact location. That is why every extra month matters. A single month of Voyager 1 data may show a new plasma change. A single magnetic field measurement may reveal how the interstellar environment shifts. A single signal may help scientists compare Voyager 1 and Voyager 2, building a better picture of the outer boundary of our solar system. The spacecraft is old, but its science is not old. Its data is still alive. And now there's another milestone approaching. In November 2026, Voyager 1 is expected to become the first human-made spacecraft to be one light day away from Earth. NASA's History of the Deep Space Network notes that Voyager 1 will become the first human-made spacecraft to reach one light day from Earth in November 2026. One light day. That means light itself needs 24 hours to cross the distance between Earth and Voyager 1. A command sent today would arrive tomorrow. Response would not come back until the day after. A simple conversation with Voyager 1 would take 2 days. No machine humanity has ever built has reached that kind of distance while still speaking back. That milestone is both beautiful and terrifying. Beautiful, because it shows how far human curiosity can travel. Terrifying, because it shows how alone Voyager 1 really is. The spacecraft is not just far away. It is becoming part of cosmic distance itself. It is moving into a place where time delays are no longer minutes or hours, but days. And still, NASA is listening. Still, the Deep Space Network points its giant antennas toward the darkness and waits for a signal almost too weak to imagine. Still, engineers read the data. Still, scientists study the measurements. Still, humanity keeps a connection with a machine launched before many people alive today were born. But that connection cannot last forever. Eventually, power will drop too low. Eventually, the remaining instruments will have to shut down. Eventually, the transmitter may not be strong enough. Eventually, Voyager 1 will send its final message. The haunting part is that we may not know it is the final message when it arrives. NASA will listen for the next signal, then the next. Engineers will check the antennas. They will check the commands. They will wait through the delay. They will try again. But one day, there will be nothing. Not because Voyager 1 crashed, not because it exploded, not because it disappeared. It will simply stop speaking. After that, Voyager 1 will keep moving. There is no atmosphere in interstellar space to slow it down. No ocean to sink into, no ground to hit. It will drift onward, carrying the golden record, a gold-plated message from Earth containing sounds, images, music, and greetings from humanity. NASA describes the golden record as carrying Earth's sounds, images, music, and greetings for any future finder. That record may outlive every city on Earth. It may outlive every language we speak now. It may keep traveling long after Voyager 1's electronics are cold and silent. That is what makes the mission feel bigger than science. Voyager 1 is a machine, but it carries something deeply human. It carries our curiosity. It carries our questions. It carries our attempt to say, we were here, to a universe that may never answer. And now NASA's final plan to save it has changed the meaning of the mission. Because this is no longer just about operating a spacecraft. It is about preserving humanity's only direct voice from the farthest frontier we have ever reached. It is about keeping the last instruments alive long enough to gather more data from a region that no human generation before us ever touched. The Big Bang plan may work. It may give Voyager 1 more time. It may keep the magnetometer and plasma wave instrument operating longer. It may extend the mission into the early 2030s. But it may also be the last major attempt NASA ever makes to save Voyager 1. That is why this moment matters. Because Voyager 1 is not dying suddenly, it is fading slowly. And NASA is trying to turn that slow fade into one more chapter of discovery. The spacecraft has already outlived its original mission by more than 4 decades. It has crossed the heliopause. It has entered interstellar space. It survived a memory failure that should have ended everything. It resumed data transmission when many people thought it was lost. And now, with only a few instruments left, it is still sending back measurements from beyond the sun's protective bubble. There has never been anything like it. And when it goes silent, there may not be anything like it again for decades. So the real question is not whether Voyager 1 can survive forever. It cannot. The real question is how much more it can teach us before the final signal arrives. NASA's Big Bang plan is not a miracle. It is not magic. It is engineering at the edge of possibility. It is a careful, risky, desperate attempt to squeeze more life out of a machine that has already given humanity more than anyone expected. And maybe that is why the story feels so powerful. Because Voyager 1 is not just running out of power, it is running out of time. Somewhere beyond the planets, beyond the heliopause, beyond the reach of repair, beyond the place where sunlight feels strong, Voyager 1 is still moving. Its signal is weak, its instruments are few, its memory has scars, its power is fading, but it is still alive. And as long as that signal continues to cross the darkness and reach Earth, humanity still has one living connection to interstellar space. One spacecraft, one final plan, one last fight against silence. And if NASA's Big Bang works, Voyager 1 may keep speaking from the darkness a little longer, but if it fails, the universe will not make a sound. Voyager 1 will simply become quiet, and the farthest voice humanity has ever sent into space will become a ghost.